All right. Good morning and good afternoon, everyone. I would like to welcome you today into our webinar where we will address how you can get immediate savings and efficiency gains in well construction. So let me first introduce myself. My name is Kenza. I'm the VP Sales and Marketing, and I'm very happy today to be presenting this webinar with Morten Svensson, our CTO. Hi, Morten.
Hello.
Hi.
How are you?
Good. So Morten has experience on using AI, predictive analytics, and digital twin technologies in well construction, and also from optimizing drilling plans to real-time optimization. Perhaps before we get started, let's just do a little housekeeping. This webinar will take about 30 minutes, including a demo and a Q&A session. And also at any time, if you have any questions, you can type them on the chat box and we will answer them at the end of this session. Okay, so we are talking today about savings and efficiency gains in well construction, and this is how we do it in e-drilling. One, by hazard prevention, and this is because prior to the operations, we have a software which can be used to acquire skills and experience on your specific upcoming well. It's focusing on how to avoid risks and how to handle them. But also during operations, e-drilling software at a very early stage detects anomalies, and crews are also provided with diagnostic messages and notifications, actually in a very good time to make the necessary adjustment. The second thing is performance optimization. And one thing to know is that the e-drilling software provides forecasting, forward-looking, and what-if analysis. And we will talk more about these later in this session. But basically, these are the features which allow for changes or change in parameters and ultimately drill the perfect well. Last but not least is avoidance of NPT. And this is achieved by using artificial intelligence and predictive analytics to foresee what will happen with your well and what needs to be done to avoid problems, including but not limited to stack pipe. We have an example where NPT was reduced by 8 to 10%, and drilling rate was improved by 20%. And this was achieved as the software helped this specific customer to have one, safer tripping and proper ECD management with less surgeon swab incidents, but also by having a better control of Wellbore friction and back reaming, which help them to prevent back-off situations. Another example from another customer is showing that NPT was reduced by 60% only in one well. And this is thanks to having early detections of loss of kicks and pipe washouts by preventing really costly incidents which could develop, and also by reduction of risks when running the casing and liners. I would like also to add that we have done a study in all the wells where our software was used. What we are proud to see and to say is that none of these wells had a sidetrack. So this is something to remember. Okay, now what you see here is our technology roadmap. And what we have today is something based on the development from over 25 years. We have a background from smart drilling, instrumentation, and cyber drilling. We then developed accurate dynamic transient downhole models used in well engineering, in advanced monitoring, and for doing drill well in simulator. And today, our technology includes AI, machine learning, predictive analytics, but also prescriptive analytics, and all these are the base for autonomous drilling control and self-drilling rigs. So back again to well construction, and when it comes to how the software is used today and helps in savings. The e-drilling software is used across the entire well construction life cycle. First thing is it's used in well engineering for its accurate capabilities. As I mentioned earlier, it's built on advanced dynamic downhole models. And beyond the accuracy, it improves safety margins and not to mention reduces the planning time. Moving to the preparation phase or before the operation, the software is also available to be used on a simulator environment. Something important to note here is that it provides you with the possibility to pre-drill your well in the simulator, but also to test procedures and equipment. And of course, this is again a saving, since it's always safer and cheaper to learn in let's say a very realistic simulator environment than doing it in a rig. Let me now talk about how it is used in real time and how it provides efficiency gains. It's actually used as a decision support tool, since it provides all the people involved in the operation, superintendents, drilling engineers, drilling supervisors. It provides them with a tool to make better decisions, to be able also to optimize the operation on the fly and avoid problems. And by having now, in addition to that, a 3D visualization of what's happening downhole, it just becomes like a GPS. The crews, for example, can see where the bit is, what's ahead of the bit, and what are the upcoming risks, which again helps in collaborative decision making. But you will get a better idea later on when we do a demo of the software. Something else is that the software can be used from anywhere or from the office. Lately, it has been used a lot from home with the current situation worldwide. But also, it's also important to know that it's a great tool to have in a drilling cabin, and we have a very good feedback from our customers using it in the rigs. Okay, over to you, Martin.
Thank you, Kenza. So let's talk a bit about the technology. And on the slide you see in front of you now, there is, we can start on the left side, where you have the typical properties of a well that is being drilled. So here you see that you have listed up different measurements that you do on the rig, but you also have other properties like the formation properties, the fluid type, and the properties of the fluid, the BHA, and so on. So what we do is that we create a digital twin of the well you are drilling using the well configuration or the statical properties of the well, and then use the real-time data to drive a digital twin. That means that we have a really good view of how the well should actually behave with all the transient phases and everything that you do to the well. But the digital twin by itself is not giving very much value, so that's why we have on the right side here, we have the value layer with the artificial intelligence and machine learning. This gives us a few opportunities. First of all, we have that we get automatic diagnostics. And that is diagnostics first on kind of the real-time operations to detect problems that is occurring. But we also have predictive analytics, where we kind of look ahead of time. We drive a separate sets of the digital twin to run it ahead of time with the current properties or current drilling parameters. And that is also triggering diagnostics. That is kind of information that says if you continue doing what you're doing now, this is going to happen. At the same time, we are also running a lot of forecasting simulations to see how are we doing according to the plan. Will we be able to reach the TD or so on, to make sure that we are actually doing the correct things. And then you have the what if analysis that is done for two different things. One is that if you actually are getting into an event, how can we avoid that event? Is there a better solution? Do we need to change our drilling parameters to not end up in a severe problem? At the same time, the what if analysis is also used to optimize the drilling parameters. That means that you have a plan that you are going to drill with this ROP, this flow rate, and so on. But in real time, we also give output that helps the drilling crews to keep optimal parameters to be able to drill as fast as possible, but also to not end up in any problems. Machine learning and artificial intelligence is quite big buzzwords in the industry at the moment, and it has shown value in many other industries. So I just wanted to kind of talk a bit about what we do in artificial intelligence. And we do a model-based reasoning artificial intelligence. That means that on the top here, you have the real system or the reality, where you have the real actual system, and that is giving an observation with an observed behavior. So that is basically the measurements that we do on the rig side. And then you have on the bottom here, you have the model of behavior or our kind of digital twin, and that is also kind of producing a predicted behavior. And then we do a comparison between those. And the comparison is, of course, some of them are quite simple, some of them are quite advanced in combination of many of the parameters that's available. That allows us to detect problems very early. We are able to see signs of problems, and by using the what-if simulations, we can find parameters that may lead to not actually ending up in problems. And kind of one of the base things here to kind of make everything work is to have a good system for detecting problems. We call it a diagnostic system, but it's basically a combination of machine learning, artificial intelligence, but also statistics or trend analysis. And these are just some examples of what we have been focusing on in e-drilling based on what we have seen that are potential problems for our customers or are of interest of our customers. And Kenza mentioned earlier about that on the wells we have been doing, there hasn't been any sidetracks. And we know that sidetracking is a severe problem in the industry that is causing the increase of the cost a lot on all the wells or many wells that are drilled. So as you see, we have had a big focus on hydraulic stuff like influxes and losses, and also problems related to surge and swap, but also when it comes to stuck pipe, hole cleaning, and pack-offs, and so on. These are just some examples. So now I was planning on giving you a very short demo of some of the system that we are providing. So I just need to share my screen if I'm able to. So now I guess you are seeing my screen. So just to start with one thing, our system is, it was originally designed as a kind of a client-server applications where you have a server connecting to the rig site or to the real-time data flow of the rig and so on, where all the calculations are done in one central place. And then you have client applications that connect to the server. That means that you could have many users monitoring one operation. So you could have the application distributed at the rig site, in a real-time offshore real-time monitoring center, or in the office, or whatever. We have, of course, come a bit further than that, because we have it also available in a cloud. That means for a small organization with maybe only a few wells running a year, there is a possibility to do a very easy deployment or integration without any effort from the IT side in the company. That means then it's available. You log on using the AD credentials, and you get access to what you have been granted access to. That also makes it much easier for also larger organizations with a lot of wells when it comes to scaling, to kind of start up and shut down operations that's as they are going on. Yeah. So what we are looking at now is one of the client applications we have, which is just, as you see, a normal plotting tool. This gives you the possibility to look at the trends of the data, compare. For example, here you have the standby pressure measured and calculated, and you can compare them as you go along. At the same time, we also have other things like the ECD and so on. We could have hook loads and torque and all these things also compared in real time. But I think we need to kind of have a look at the visualization where we use 3D to do this. As you can see on the screen I'm sharing now, you see that there is actually quite some data that is located there. You see that we have a lot of offset wells in the area where we could have a lot of information about all the offset wells or the interesting offset wells. We have the formation tops that also gives you a potential to actually see a bit, understand a bit where you are drilling at the moment. We also have some gauges here that makes it kind of easy to see, get access to some single values. In this case, we are just monitoring the flow in and flow out. We have the gain loss indicator, and we also have the standby pressure. But this could be kind of set up to be whatever you want. So let's zoom in to have a look at what we see in the Wellbore. So what we see now here is that we have also along the well we're actually drilling, we have these colors that is around the well. And these are actually plots showing this is the ECD for the entire Wellbore. We have the temperature in the entire Wellbore, and the green on the downside is actually the cuttings concentration in the well, which is modeled for each time step. We are modeling what is happening in the well. That gives a good, when something happens, you could very easily see where the potential problem is when it comes to, for example, cuttings. Let's zoom in. Now you start seeing some icons with some information. And if I zoom in even closer, this is something that we already have been drilling, and we can start from the top. So here you actually have an automated detection of a drilling break with a first action. And the first actions is something that we have configured the system with, but we always configure that based on the company procedures that you would have. So if your procedure said that the first action for a drilling break, it would say that you're going to do a flow check. At the same time, we also have these virtual sensors showing here the ECD at the casing shoe. We have the recorded FIT at the casing shoe, and so on. We have also some other information here that we appeared while drilling. We had a low ECD warning, which is a pretty generic warning, but it actually tells that the ECD is lower than expected. We also have information about the tight spot. This is a message that is added in by the mud logger in this case. so it's easy to track it, where it is, and to see it afterwards. And also there was a message here about pore hole cleaning, and also first actions, what to do about that. This is just a kind of playback that I've done. In a newer version, we will also get information about recommended parameters to use on the reduced ROP and the flow rate. We also have a pack of detection with also first action. If we go down a bit more, you see also that we also had a stringer that was detected while drilling here later on, and so on. And this is something that we see is giving, we have drilled a bit far away here. We see that using this tool in real-time operation, so if I set it down here, even the driller can have this screen and look down while he is drilling, and look upwards while he's stripping out. This means that you could also have all the information about the risks that is associated with the well, and the driller can actually see ahead what is the risks, and he can have his drilling parameters or his drilling program inside to the application. That means that he doesn't need to have a paper with all the kind of the detailed operational plan, but he could have everything in this screen, and at the same time get the recommendations, get the warnings as he is doing the job. Yeah, I think that was everything I wanted to show. So
thanks, Martin.
Stop sharing my screen.
Yeah, thanks, Martin, for this fantastic demo. So let's continue with the presentation. And I hope now that you all can see that this is not a legacy software or renaming of a good old steady state solution, but actually is real change for real savings. And for those wondering about who is using our technology today, this is our client showcase, which includes E&P companies, service companies, drilling contractors, and it's actually being used globally. Now, if you're also wondering how this can help you with your specific type of operational challenges, just get in touch with us. We can do a replay of one of your wells, or we can do planning optimization in your existing drilling operational plan. And this is, of course, without any cost, so just please contact us. All right, so maybe we can now go ahead and take some time for questions.
Yeah, I see there is a question about stuck pipe. Let's see, stuck pipe prediction. Does this include all types of stuck pipes, all types of trajectories? I think the short answer would be yes. And that means that we are not, except for one thing, we are not that kind of, we are not predicting that what's called that we are getting differential stuck. We don't predict that is happening at the moment, but we are seeing, we are all the time monitoring and observing, or the system is doing that to detect when a problem starts happening. That means that if you, while you're up drilling and on one connection, and we see that you're actually, the system sees that there is a differential stuck, you get information about that, so that you have that information, and that is used for later on to detect if it gets more severe than it was. The same with other stuck events, like related to hole cleaning, for example. That is also predicted while drilling or whatever you're doing. But I think it's important to think that since the system is monitoring all the kind of available parameters of the operations, it finds signs of problems early. And the goal of the system is not to kind of tell you that you are stuck. The goal is to optimize so that you don't end up getting stuck. That means that if there are signs of poor hole cleaning, it will give you advice on how to change your parameters to avoid that.
Yeah.
And there's another question as well. Besides stuck pipe, what other drilling problems could be predicted or simulated? And I think we need to separate between predicted and simulated here. But if you say if we look at the prediction part now, we have a very high focus on hydraulics in e-drilling. That means that we have a very good ways of detecting problems related to gains or losses when it comes to search and swab. When it is stripping, the system does calculations for you to avoid getting into search and swab problems. It also gives you warnings in real time when it comes to search and swab if you're getting close to the limits that's there. But it also other things on equipment failure, like washouts in a drill string or something like that. But it's basically all the kind of common problems within drilling. But if you say when we think about simulated, I need to kind of tell you that e-drilling has more products than we are actually talking about here. And we have modules for doing simulations when it comes to well control, to do dynamic well control simulations to predict how you should actually handle this type of kick, which method to select, and so on. Also, when it comes to kick tolerance, we do dynamic kick tolerance simulations. Which has a great level of detail to find, for example, about casing shoe placement or and so on. The same thing with other hydraulic problems. Also, different technologies like doing simulations in the managed pressure drilling or dual gradient drilling. But that's also kind of supported in the real-time system, where we kind of also help or calculate based on in MPD, for example, using the measured choke pressure to actually calculate the correct values in the well, but also the other way around to actually give you the recommended choke pressure, for example.
Yeah, thank you, Martin. Maybe perhaps we can take one last question since we are running out of time.
Yeah.
There is a question about will the driller have notifications on upcoming hazards? And I guess the answer is yes, completely. And in fact, some of our clients have this 3D visualization on the drill floor, so they can see all the risks and be aware of any upcoming hazards. So I hope this answered the question. All right, so this concludes our webinar today. Thank you very much for everyone. We appreciate you being here. And if you have any further questions, please don't hesitate to send me an email. Okay, thanks again, and we will see you next time.
Thank you. Bye all.